Learning objective. A linked list is a collection of data elements called nodes in which the linear representation is given by links from one node to the next node. In this chapter, we are going to discuss different types of linked lists and the operations that can be performed on these lists. We have studied that an array is a linear collection of data elements in which the elements are stored in consecutive memory locations. While declaring arrays, we have to specify the size of the array, which will restrict the number of elements that the array can store. For example, if we declare an array as int marks 10, then the array can store a maximum of 10 data elements but not more than that. But what if we are not sure of the number of elements in advance? Moreover, to make efficient use of memory, the elements must be stored randomly at any location rather than in consecutive locations. So, there must be a data structure that removes the restrictions on the maximum number of elements and the storage condition to write efficient programs. Linked list is a data structure that is free from the aforementioned restrictions. A linked list does not store its elements in consecutive memory locations and the user can add any number of elements to it. However, unlike an array, a linked list does not allow random access of data. Elements in a linked list can be accessed only in a sequential manner. But like an array, insertions and deletions can be done at any point in the list in a constant time. A linked list, in simple terms, is a linear collection of data elements. These data elements are called nodes. Linked list is a data structure which in turn can be used to implement other data structures. Thus, it acts as a building block to implement data structures such as stacks, queues, and their variations. A linked list can be perceived as a train or a sequence of nodes in which each node contains one or more data fields and a pointer to the next node. In Fig. 6.1, we can see a linked list in which every node contains two parts, an integer and a pointer to the next node. The left part of the node which contains data may include a simple data type, an array, or a structure. The right part of the node contains a pointer to the next node, or address of the next node in sequence. The last node will have no next node connected to it, so it will store a special value called null. In Fig. 6.1, the null pointer is represented by x. While programming, we usually define null as 1. Hence, a null pointer denotes the end of the list. Since in a linked list, every node contains a pointer to another node which is of the same type, it is also called a self-referential data type. Linked lists contain a pointer variable start that stores the address of the first node in the list. We can traverse the entire list using start, which contains the address of the first node. The next part of the first node in turn stores the address of its succeeding node. Using this technique, the individual nodes of the list will form a chain of nodes. If start equals null, then the linked list is empty and contains no nodes.